Okay, so Assalamualaikum warahmatullahi wabarakatuh. Tak tahulah, tengah tengok ni waktu bila, morning. So good afternoon, good morning, good evening, good night. Semua sekali lah kiranya. Okay, so let us start with the first set. So like I promised to you, I'll record a video and then afterwards I think I'm gonna make sure I send you a copy of this. Okay, so let us do question number 1. So let us read the question together. So find dy over dx for the following equation. So the first one, we have y equal to 3 e to the power of 2x plus 1. Okay, so let me write down the question then. So y is equal to 3e to the power of 2x plus 1. So how do we differentiate this? Okay, so basically you have some constant, so bring the constant down. And then if you have some exponent, then what do? Copy down the exponent together with the power, but then we have to differentiate the power. So differentiating 2x plus 1, that is simply equal to 2. So we got 3e 2x plus 1 multiply with 2. And then 3 will be multiplied with 2. So this is equal to 6 e to the power of 2x plus 1. Okay, so now done with this. So let me group them first. And then we can move on to B. Right, so now how to answer B? Let me choose another color. So 1B. So we got y is equal to sine of 2 minus 3x. So differentiate sine. So dy over dx. Differentiate sine, we are going to get cos. So cos of whatever we have at the back. And then of course we need to differentiate 2 minus 3x. So differentiating 2 minus 3x will give us negative 3. So what do we have is cos of 2 minus 3x, and then everything need to be multiplied with negative 3. So my answer will be negative 3 cos of 2 minus 3x. Okay, so that is for B. So let us move to C. But before that, again, let me do a group for this. Okay, so number 1C. So we got y equal to x squared over 3 minus x. So obviously you have a fraction over here. Therefore, in order to differentiate them, I need to use a quotient rule. So it will be vu prime minus u v prime over v squared. Okay, so y is equal to x squared over 3 plus x. So let us calculate dy over dx. Okay, so v first. So we got 3 plus x. Differentiating x squared, we are going to get 2x minus x squared. Differentiating 3 plus x, so it will become 1 over 3 plus x squared. Okay, so we're going to simplify our numerator a little bit. So we got 3 times with 2x. So 6x plus 2x squared minus x squared over 3 plus x squared. Okay, so simplify. I have 2x squared minus x squared, so it will become x squared plus with 6x over 3 plus x squared. So factorizing the x for my numerator, I will have x plus 6 over 3 plus x squared. Okay, so that is basically for question number 1. Okay, again, let me group this one first so that we can move to the second question. So I'm doing option number 1 and option number 2 together then. Okay, so now question number 2. Find the limit of the following if it exists. Okay, So number 2a, the limit for x approaches 4. Right, so number 2a, the limit for x approaches 4 of x minus 4 over 4 plus 3x minus with x squared. Okay, so again, if let's say we do see something with a limit, not again, this is the first time good. Okay, so this is the limit for x approaches 4 for x minus 4 over 4 plus 3x minus x square. So try to substitute first. So apa-apa pun kalau kita jumpa limit, try to substitute first. Okay, so if you do try to substitute, you're going to see that if you do substitute x with 4, so we're going to end up with 0. Substitute with x equal to 4 for our denominator, so we are going to get 4 plus with 12 and then minus with 4 square, which is also equal to 0. So we do end up with 0 over 0. So if we have 0 over 0, it can mean two things. So you can either factorize them or you can multiply with the conjugate. So obviously I don't have anything with a set, so I'm going to factorize them. So we're going to factorize our denominator. So this is the limit of x approaches 4 of x minus 4 over, so my denominator, I have x, 4, 1, 4, x, positive 3x, so positive, negative then. So I got 4 minus x and 1 plus x. Okay, so these two, I can actually simplify them. So I'll be left with negative 1. So this is the limit of x approaches 4 of negative 1 over 1 plus x. And substitute x with 4, we are going to get negative 1 over 5. Okay, so that is question number 2a. So again, let me group this one first so that we can do another question. Okay, so question number 2b. So we want to find the limit as x approaches 25 of x minus 25 over square root of x minus 5. Okay, so if you do try to substitute with x equal to 25, we are going to get 25 minus 25, which is 0. Square root of 25 is 5, so 5 minus 5, that is also 0. So we do end up with 0 over 0. It can mean two things. So we should either factorize them or multiply with the conjugate. So I do see something with a set, so I'm going to times with the conjugate. So this is the limit of x approaches 25 of x minus 25 over square root of x minus 5 multiply with square root of x plus 5 over square root of x plus 5. Okay, so when you times with its own conjugate, then you expand. Otherwise, you're going to leave them inside a bracket. Okay, so untuk atas ni, dia bukan conjugate of each other. So I'm going to leave them. So this is the limit of x approaches 25 of x minus 25 square root of x plus 5 over be extra careful when you want to expand them. Set x, so it will become x, negative 5, positive 5, it will become negative 25. And the other two terms will just cancel out each other, so I'm going to left with x minus 25. So cancel those two. So we are left with the limit of x approaches 25. So this is the limit of x approaches 25 of square root of x, square root of x. The limit of x approaches 25, square root of x plus 5. So this is simply equal to set 25, which is 5 plus 5. Therefore, this is equal to 10. Okay, so done with this one. Again, let me group this one first. And then we're going to do answer question C. Okay, so which color? I think this one look quite nice. Okay, so this one then. Right, so C, we got a limit as x approaches infinity, and then we got the square root of 3x to the power of 4 plus with x over x square minus with 6. Okay, so now let's see. Right, so if I do try to substitute with infinity, I'm gonna end up with having infinity over infinity. So if we have infinity over infinity, this is indeterminate form. Therefore, the only way to solve this is that we need to divide with the highest power of denominator. Okay, so what is the highest power for our denominator? So as we can see, the highest power is x squared, so I'm going to divide with x squared. So this is the limit x approaches infinity, square root of 3x to the power of 4 plus x over x squared minus 6 over x squared. Okay, so basically in our denominator, that is fine, we can actually divide them. But in our numerator, we got some problem over there, because in our numerator, we have something with a set. In our denominator, we don't have something with a set. So we must change it into a set as well. Okay, so x squared. X squared can be the square root of x to the power of 4. So this is the limit. Okay, so this is the limit of x approaches infinity. The square root of 3x to the power of 4 plus x over x to the power of 4 over x squared minus 6 over x squared. So now let me simplify both of them. Okay, so this is actually the limit of x approaches infinity, the square root of 3 plus 1 over x cubed over 1 minus 6 over x squared. So substitute with x equal to infinity. So 1 over infinity is 0. 6 over infinity, that is also 0. So I do end up with square root of 3 over 1, which is simply equal to square root of 3. And we are done with question number 2. So again, let us group this together, and we can answer question number 3 after that. So never mind, I think I'll do the rest later on. Nantilah, lepas ni baru saya anjak-anjak borang kotak kasih cantik sikit. Alright, so let us answer question number 3. Okay, so what is question number 3? Given that fx is equal to x cubed minus 3x squared minus 9x plus 11, find the stationary point of the function and determine the nature of the point. Okay, so stationary point, it means that we need to know what is the value when f prime of x equal to 0. Determine the nature, that means I should calculate where is the minimum and where is the maximum. Okay, so let me start with the function first. So fx is equal to x cubed minus 3x squared minus 9x plus with 11. So let us differentiate this. So f prime of x, this is 3x squared minus 6x minus 9. So let me differentiate them again to get the second derivative. So this is 6x minus 6. Okay, so let f prime equal to 0. So we got 3x squared minus 6x minus 9 equal to 0. So divide everything by 3. So x squared minus 2x minus 3 equal to 0. So we will have either x minus 3 or x plus 1 equal to 0. So either x equal to 3 or x equal to negative 1. Okay, so when x is equal to 3, so f double prime of 3 is equal to 6 times 3 minus 6. So this is equal to 18 minus 6. So this is 12. 12 is greater than 0. So since we do have something that is greater than 0, I do know this is definitely a minimum point. Okay, another one. When x is equal to negative 1, so f double prime of negative 1 is equal to 6. Multiply with negative 1 minus with 6. So this is negative 12 less than 0. So that is definitely a maximum. So the question asks for the stationary point, so I need to give them the y coordinate as well. So f of 3 is equal to 3 cubed minus 3 times 3 square minus 9 times 3 plus with 11. So this is 27 minus 27, cancel out. So negative 27 plus 11, so that is negative 16. Another one is f of negative 1. So we got negative 1 cube minus 3 negative 1 square minus 9 times with negative 1 plus with 11. So we got negative 1, and then over here we got negative 3. So this is negative 4. Negative 4 plus with 9. Negative 4 plus 9. This is 5. 5 plus 11. So this is positive 16. Okay, therefore, our stationary point so our stationary points are 3, negative 16, and we got negative 1, 16. And then 3, negative 16 is a minimum point. And negative 1, 16 is a maximum point. Okay, so well done. Very good. We have already finished part A, so let us move to part B. Alright, so let us start with B then. Okay, so number 1A, simplify. Okay, so we should simplify them. Number 1A, so I have 4 multiply with 3 to the power of n minus 27 multiply with 3 to the power of n minus 2 over 3 to the power of n plus 3 minus with 8 multiply with 3 to the power of n plus 1. Okay, so firstly, let me separate 3 to the power of n. So this is 4 multiply with 3 to the power of n minus 27 times 3 to the power of n times 3 to the power of negative 2 over 3 to the power of n, 3 to the power of 3 minus with 8 multiply with 3 to the power of n, 3 to the power of 1. Okay, so now I'm gonna factorize 3 to the power of n because everywhere I have 3 to the power of n. Okay, so let me factorize 3 to the power of n because I have 3 to the power of n for each of them. So I'm gonna factorize 3 to the power of n. Dia macam hang sikit lah. So this is 3 to the power of n, and now we got 4 minus 27, and 3 to the power of negative 2 is actually 1 over 9 over 3 to the power of n, and then we got 3 cubed over there, which is 27, minus with 8 times 3, so minus 24. So these two will cancel out, so we are left with 27 over 9. So this is 3, 4 minus 3 is 1 over 27 minus with 24, therefore the answer is 3. So when we simplify them, we are going to get 1 over 3. Okay, again, some space for the next question. Okay, so now number 1b, express the complex number z equal to 1 plus I. So z is equal to 1 plus I over 1 minus 2I in the polar form. Okay, so before you start in polar form, you got to make sure that z must be in Cartesian form first. So I need to change this in the form of a plus bi. So I need to have I only in the numerator. So I must times this with the conjugate first. So this one times with 1 plus 2I over 1 plus 2I. Therefore z will be equal to, so 1 times 1, 1, 1 times 2I, 2I, I times 1, I times 2I, positive 2I square, over 1 times 1, 1, plus 2I, minus 2I, and then minus 4I square. So this is equal to, so negative 1 is equal to I square is equal to negative 1. So this is equal to negative 1. This is also equal to negative 1. And I can cancel out these two. So what do I have left? Is 1 minus 2, which is negative 1, plus 3I over 1 plus 4, which is 5. So I have z equal to negative 1 over 5 plus 3 over 5I. So my z is already in Cartesian form. Then I can easily calculate the modulus as well as the argument. Okay, so now modulus of z. So this is equal to the square root of negative 1 over 5 square plus 3 over 5 square. So this is actually the square root of, so 1 square is 1 over 25 plus with 3 square, which is 9 over 25. So this is actually the square root of 10 over 25. So you can actually simplify them. So this is square root of 2 over 5. So square root of 2 over 5. Okay, so that is the modulus. So now let us calculate the argument. But before I check what is the argument, we need to draw the Argand diagram first. So I have the real axis, the imaginary axis. So negative 1, that means the real number is negative. So over here then, negative 1 over 5. Positive imaginary, so up here 3 over 5. Therefore, this is our z. Actually, it should meet at 0. So let me draw that again. Nak kena jumpa dekat kosong. Nampak macam sengit kan. So, jap. Oh, terror. Okay, so now what is the argument? Argument always start from the real number, the positive one. So this is our theta, or the argument. Okay, so basically how to get the argument? Okay, so for the argument will be equal to pi minus with arctangent of modulus. Okay, so b over a, so I'm supposed to have 3 over 5 over negative 1 over 5. So this is equal to pi minus arctangent 3 over 5 3 over 5 over 1 over 5. So this is arctangent of 3. And then you can use your calculator. So the answer for this will be 1.89 within. Therefore, z is equal to r. R is our modulus of z, which is square root of 2 over 5 r cos theta, so cos 1.89 plus I sine 1.89. So that is our polar form. Okay, so done with this, let me proceed with the next question. Okay, so question number 2A. So we got a log to the base of 3x plus log to the base of x3 equal to log 9 3 to the power of 6. Okay, so normally for me, I prefer to check the base first. Okay, so let us check the base first. So this is 3x, this is 9. So we don't have a similar base, so I got to change everything into a similar base first. So I think I do like the number 3 as my base, so I'm gonna change everything into log to the base of 3. So this is log to the base of 3x. I didn't really change anything, but over here I should change this. So this is 1 over log to the base of 3x. This is equal to, so change of base, log 3 to the power of 6 over log 3 of 9. Okay, so this one is simply log 3x plus 1 over log 3x, and then this is equal to so this one I'm going to bring the power down, so 6 over, so 9 is actually 3 square, so this is 6 over 2. So we will have log 3x plus 1 over log 3x equal to 3. Okay, so let me separate this. So this is actually log of 3 plus log to the base of 3x, because if we do a plus between them, you're gonna times the number behind it. So plus 1 over log 3x, and this is equal to 3. So log 3 is 1, so I have 1 plus log 3x plus 1 over log 3x, and this is equal to 3. So log 3x plus 1 over log 3x, 1 minus 3, so negative 2 equal to 0. So now I'm gonna use some substitution to solve this. So I'm gonna let y equal to log 3x. So I have y plus 1 over y minus 2 equal to 0. So y square plus 1 minus 2y, this is equal to 0. So y square minus 2y plus 1 equal to 0. Therefore, y minus 1 square is equal to 0. Y is definitely equal to 1. So log 3x is definitely equal to 1. X will be equal to 3 to the power of 1, and 3 to the power 1 is simply equal to 3. Okay, so that is the value for this question. Okay, so jom kecilkan sikit, lepas tu kita jawab soalan yang berikutnya. Okay, hari ni kalau dengar suara macam down, bukan down tau. Sebenarnya hari quite tired, so sebab tu suara dia macam slow sikit. Hari slow sikit suara. Dia macam dah nak tidur tapi tak boleh tidur sebab kena buat ini dulu. So sebab tu kalau dengar suara macam penat sikit tu, bear with me dan tak boleh nak buat apa. Okay, so number 2B now. Okay, so we got 3 over x less than or equal to 4 over x minus 1. So I'm going to bring everything to the left hand side first. So 3 over x minus 4 over x minus 1 plus 1 less than or equal to 0. And then let us have a common denominator. So we got 3 times with x minus 1 minus with 4 multiply with x plus with x multiply with x minus 1. And then everything divide with x minus 1 less than or equal to 0. So let us simplify our numerator. So we got 3x minus 3 minus 4x plus x squared minus with x over x minus 1 less than or equal to 0. Okay, so let me simplify. So this one is x squared, 3x minus 4x is negative x, so negative 2x, negative 3, and no more constant, so simply negative 3 over x minus 1 less than or equal to 0. So this one will become x minus 3, x plus 1 over x minus 1 less than or equal to 0. Okay, so in order to solve this, we need to draw a real number line. Okay, so now we need to draw a real number line for them. So let me take for our numerator first. So I have x minus 3 greater than or equal to 0, x greater than or equal to 3, another one x plus 1 greater than or equal to 0, x greater than or equal to negative 1. For my denominator, so I have x greater than 1 only, so we don't have the equal sign because this is basically for my denominator. Another one is x minus 1, so this is also greater than 0 only, so x is greater than 1. So lagi sekali tak ada simbol equal sebab dua bahagian ni adalah untuk denominator. Okay, so let us draw the number line. So ni yang bahagian bawah tu. Okay, so what are the numbers? So on the left hand side I have negative 1, so paling kiri negative 1, and then I have 0, I have 1 as well as 3. So everything go to the right hand side. So let me do the arrow going to the right hand side. So over here going to the right hand side. Okay, going to the right hand side as well. And then another one going to the right hand side. And I don't have the space anymore. So bear with me, I need to rearrange this a little bit. Okay, this one go down. Okay, and this one perhaps we need to do some modification. Okay, another one. Okay, so now let us write down the sign then. Oh, before that, we need to refer to the circle. So at 3, this is greater than or equal, so a dense circle. Greater than or equal to negative 1 as well, so a dense circle. This one must be open, this is also open. Okay, so we are assuming them. So this is the part where we assume them to be greater than 0. So on top of the line, we should always write down positive then. So the region without the line, it will be negative. So positive, 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 negative, positive, negative, positive. Okay, so now refer to the question. So I want something that is negative. So the only region that will give me negative is somewhere in between negative 1 and 0, as well as 1 and 3. So that means the final answer will be negative 1, 0, as well as 1, 3. So in order to know what kind of bracket you should do, you should check, do you have a dense or an empty circle? So a dense will be a square bracket. This one will be empty. This one empty, 3 dense. So I got 2 different interval. So union then. So my answer is either in the first interval or in the second interval. Okay, so done with this question. So let us proceed with the next one. Okay, so let me answer question number 3 now. Okay, so question number 3, given that fx is equal to kx minus 1 over x plus 2, x cannot be equal to negative 2, otherwise we have something that is undefined. Find the value of k such that f inverse of x plus k is the negative of 3 over x plus with 2. Okay, so firstly, let us calculate what is the f inverse. So fx is equal to kx minus 1 over x plus 2. So we're going to do f composite with f inverse equal to x. Therefore, k f inverse of x minus 1 over f inverse of x plus 2 equal to x. So I'm going to bring my denominator to the right hand side. So k f inverse of x minus 1 equal to x multiply with f inverse of x plus with 2x. Bring f inverse to the left hand side. So we got k f inverse of x minus x f inverse of x equal to 2x plus with 1. So that means f inverse of x multiply with k minus x equal to 2x plus 1. So f inverse of x is equal to 2x plus 1 over k minus x. Okay, so we have been given f inverse of x plus k. So f inverse of x plus k, this is equal to negative 3 over x plus 2. Negative 3 over x plus 2. Let me check again. Okay, correct. Okay, so now let me substitute the x with x plus k. So over here I have 2 times with x plus k plus with 1 over k minus x plus k equal to the negative of 3 over x plus with 2. Okay, so simplify a little bit. We got 2x plus 2k plus 1 over, so this is k minus x minus k, so k minus k, so this is negative x equal to the negative of 3 over x negative 2. Okay, so let me simplify this. So this one will become negative 2 and then plus with 2k plus 1 over negative x. So this is basically negative 3 over x negative 2. Okay, so by comparing, so we should be able to see that negative of 2k plus 1 over x is equal to negative 3 over x. So that means 2k plus 1 must be equal to 3. So 2k must be equal to 3 minus 1, which is 2. Therefore, k must be equal to 1. Okay, so done with this question. So let us proceed. Let us proceed with the next one. Okay, so tadi dia hang jap. So ini dah okey sikit. So saya kecilkan sikit. Lepas tu kita boleh buat soalan nombor 4 pula. Warna apa? Ini kot. Macam okey. Okay. Grupkan dan kecilkan. Okay, so question number 4 now. Okay, so a function f is defined by fx equal to ln 2x minus 5. State its domain and range. Okay, so number 4a. fx is equal to the ln of 2x minus 5. So in order to know the domain, so the domain will be 2x minus 5 greater than 0. So x will be greater than 5 over 2. So my domain, you can write down x greater than 5 over 2, or you can write down the domain as 5 over 2 up until infinity. Meanwhile, the range for the ln is always negative infinity to infinity. So that is for number 4a. By using algebraic method, show that fx is one-to-one function. So algebraic method, so I'm going to start with fx1 equal to fx2. So I have ln of 2x1 minus 5 equal to ln 2x2 minus 5. So since I have ln on both sides, I can easily compare the number behind. So 2x1 minus 5 equal to 2x2 minus 5. Adding with 5 on both sides, so we got 2x1 equal to 2x2. Divide them by 2, so I have x1 equal to x2. So since fx1 equal to fx2 implies that x1 equal to x2, therefore f is one-to-one function. Therefore fx is one-to-one function. Okay, so let me do C, find the inverse of f. Okay, so I'm gonna do f composite with f inverse equal to x. So f composite with f inverse equal to x. So ln of 2 f inverse of x minus with 5 equal to x. So 2 f inverse of x minus 5 equal to e to the power of x. So f inverse of x will be equal to e to the power of x plus 5 over 2. Okay, so now we can sketch them on a single diagram. So let us sketch them now. Okay, so kita draw graph 2. Okay, so what is fx? So fx is ln of 2x minus 5. Okay, so f prime, this is ex plus 5 over 2. Okay, so let me sketch the y and the x-axis. Okay, so for the ln, we need to have our vertical asymptote. So the vertical asymptote will be at x equal to 5 over 2. So let me draw a vertical asymptote for that, 5 over 2. So this is 5 over 2. Okay, so now the vertical asymptote is 5 over 2. And then if you check, the coefficient of the x is positive, the coefficient of the y is, the coefficient of the ln is positive as well. So I do know it should go to the positive and positive. So we're going to start from here and we are going to push our asymptote. So something like this. Dia shaky sikit sebab saya punya tangan lah, tapi sepatutnya dia okay je. Okay, and then another one. So this is also 5 over 2. 5 over 2. Right, so basically I'm gonna flip this. So it will start another one, y equal to x. Oh my graph. Okay, I think better for me to draw this again. It doesn't look quite nice. Okay, so let me draw this again. Okay, so the other one is somewhere over here. Okay, so this is fx. This is f prime. F inverse. Oh, yang ni pun saya tulis f prime Oh, sorry. Tak sengaja. Okay, so f inverse. By the way, label everything. So this is y equal to x, f inverse, and then yang ni dia sentuh, so kita kena kira lah nilai dia berapa. Okay, so kita tengok what is the value, so that if I do substitute with the value of x, I'm gonna get 1 over here. So this one must be 3 then. 2 times 3, 6. 6 minus 5, 1 ln 1 is equal to 0. That is 3. This is also 3 then. Okay, so other than that, maafin ya, dia punya graph ni tak berapa smooth sangat. Sebab saya tak boleh lah, kalau saya padam dia tak ni juga. So I'm gonna leave them first, and then later on I'll come back to this part. So math sekejap saya kecilkan sikit, so that we can do the other question. So groupkan dulu, dan kita kecilkan. Saya rasa mungkin sebab saya duduk kecil-kecilkan dia ni kot, dia hang sikit. Sebab dia ada banyak sangat dokumen kat dalam ni. So that is question number 4. So let me proceed with the next question. Question number 5. Okay, so question number 5, A. Find the value of P and Q that will make this one continuous for all real values of X. Okay, so let us do the number line first. So I got 2 over here, 3 over here. Less than 2 is X plus 2. And then I have 1 over 2 Px square minus Qx plus 3. And then this one over here, X greater than 3. 2x minus p plus q. So it should be continuous. That means the limit as x approaches 2 on the left hand side, so the function is x plus 2. So this one must be equal to the limit of x approaches 2 on the right hand side of half bx square minus qx plus with 3. So substitute x with 2, so we got 2 plus 2, which is 4, equal to half of p multiplied with 4 minus with 2q and then plus with 3. So 1 is equal to, so 2, so 2p minus 2q is equal to 1. So that means p minus q is equal to 1 over 2. So that is the first equation. The other one, I'm going to compare the limit for x approaches 3 on the left hand side. So the function is half bx square minus qx plus with 3. So this is the limit of x approaches 3 on the right hand side. 2x minus p plus with q. So substitute x with 3. So we are going to get half b. 3 square is 9 minus q times with 3 plus 3. This is equal to 2 times 3, 6 minus p plus q. Okay, so this one will be 9 over 2p minus 3q. So this is plus p minus q equal to 6 minus 3, which is 3. So 9 over p plus p, so 11 over 2p. And then negative 3, negative 1, so negative 4q equal to 3. So let me times everything by 2. So 11p minus 8q is equal to 6. Okay, so from here, I'm going to get the third equation. So this is the second equation. So p is equal to half plus q. So that is the third equation. So I'm going to replace p equal to that value. So I have 11 times with half plus with q minus 8q equal to 6. So 11 over 2 plus 11q minus 8q equal to 6. So 11 minus 8 is 3q equal to 6 minus 11 over 2. So 12 minus 11, 1 over 2. So q will be equal to 1 over 6. So since q is equal to 1 over 6, so p will be equal to 1 over 2 plus 1 over 6. So 6 plus 2, 8, 8 over 12. So divide them by 4. This is 2. Divide them by 4, 3. So b is equal to 2 over 3. Okay, so done. Okay, so let us answer question number 5b. So this is the limit as x approaches 0 for 2 over x minus 2 over x square root of x plus 1. Okay, so let me change this into a single fraction first. So this is the limit for x approaches 0, and then I have 2 square root of x plus 1 minus 2 over x square root of x plus 1. Okay, so perhaps let me simplify this a little bit. So this is the limit for x approaches 0, 2 square root of x plus 1 minus 1 over x square root of x plus 1. Okay, so if I do try to substitute x with 0, I will get 0 plus 1, which is 1. 1 minus 1, so this is 0. Substitute x with 0 over here, that will also give me a 0. Therefore, I should get rid of the term that will give me 0 over 0. So in this case, I choose to times with the conjugate. So this is the limit as x approaches 0. So 2 square root of x plus 1 minus 1. So I'm going to times them with the square root of x plus 1 over 2 square root of x plus 1 multiply with square root of x plus 1 plus 1. Okay, so we're going to expand our numerator. So this is the limit for x approaches 0. So I have 2. So set times set. So it will simply be x plus 1, negative 1, positive 1. So negative 1 over 2. Why do I have a 2 over there? So let me get rid of that. So, all of a sudden tiba-tiba terletak 2. Tak apalah. Sepatutnya x kan, tertukar jadi 2. X. Okay, so this is x, and then square root of x plus 1, and then square root of x plus 1 plus 1. So substitute, simplify first. So this is the limit of x approaches 0, 2. So it will become 2x over x, square root of x plus 1, square root of x plus 1 plus 1. So get rid of the x. So I no longer have anything that will give me 0 over 0. So congratulations to myself. So this is 2 over square root of x plus 1 times with square root of x plus 1 plus 1. And now we're going to substitute x with 0. So we got 2 over, so 0 plus 1, which is 1. And then I have 0 plus 1, 1, 1 plus 1, which is equal to 2. And the final answer for this is simply equal to 1. Very good. So now let us proceed with the next question. So sorry lah, tadi ada tersalah tulis sikit. Tak apa, you do know and you do notice, right? Okay, group first. And then let us do question number 6. Okay, so question number 6, given the parametric equation, so 6a, so I have x equal to 3 cos 2t, and I have y equal to 12 sin t, and they want us to show that dy over dx is negative cosecant t. Okay, so let me differentiate this first. So differentiate this dx over dt. So simply copy down the constant, differentiate cos, I'm going to get negative sine of 2t, and then we are going to differentiate 2t, which is 2. So this one will be negative 6 sine of 2t. So this is dx over dt. Meanwhile, for the y is equal to 12 sine t, so dy over dt is equal to 12 cos of t. And then we're going to find out what is dy over dx. So dy over dx is simply dy over dt multiplied with dt over dx. So dy over dt is 12 cos t over negative 6 sin 2t. So 12, 6, so this is 2. So we are going to get negative 2 cos t over, so sine of 2t, we can actually change it to become 2 sin t cos t, and then you can cancel out the cos and cos, 2 and 2. So we have 1 over sine, which is actually negative cosecant of t. So negative, 1 over sine is cosecant of t. Okay, so I'm done with number 6a, so let us proceed with the next one. Okay, so the next one, perhaps a green will do. Okay, so B, number 6b. A function f is defined by blah 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 blah. Determine whether the function is differentiable at x equal to 1. So in order to know whether a function is differentiable at x equal to 1 or not, I have to check what is the limit for x approaching 1 on the left hand side as well as right hand side. So we're going to use the formula. So f prime of 1, so this is the limit as x approaches 1 on the left hand side. So the function is this one, negative 1 over x square minus, so negative 1 minus 1 over 1 square over x minus 1. Okay, so this is the limit for x approaching 1 on the left, negative 1 over x square, negative. Okay, so 1 over 1 square, so this is 1, negative 1 is negative 2. So this one gonna be positive 2 over x minus 1. Okay, so simplify. This is the limit for x approaching 1 on the left. So this one is negative 1 over x square plus with 1 over x minus 1. So let me change this one into a single fraction. So this is the limit for x approaching 1 on the left hand side of x square minus 1 over x square x minus 1. So if we do try to substitute with x equal to 1, we are going to get 0 over 0. So that means I should factorize my numerator first. So this is the limit for x approaching 1 on the left hand side, x plus 1, x minus 1 over x square x minus 1. Then cancel out x minus 1. So this is the limit for x approaching 1 on the left hand side of x plus 1 over x square. So substitute x with 1, 1 plus 1 is 2, 2 over 1 is simply 2. Okay, so on the left hand side I have the value which is 2. So now let us check on the right hand side. No space, so I have to go down. Okay, so another one, f prime of 1. So this is the limit for x approaching 1 on the right hand side. So I have to refer back. What is the function? 3 minus x squared. Oh, thank goodness, the function is very nice. Okay, so we got 3 minus x squared minus 3 minus 1 square over x minus 1. So this is the limit for x approaching 1 on the right hand side. So 3 minus x squared, 3 minus 1 is 2, so this is negative 2 over x minus 1. So this is the limit for x approaching 1 on the right hand side. 3 minus 2 is 1, so I got 1 minus x squared over x minus 1. And then if you do try to substitute x with 1, we are going to get 1 minus 1, 1 minus 1, 0 over 0. So we're going to factorize our numerator. So 1 minus x, 1 plus x over x minus 1. So these two will cancel out. So I will be left with negative 1. So substitute x with 1. So we are going to get 1 plus 1 over negative 1. So the answer for this one is negative 2. Therefore, the value is not equal, right? So this is negative 2, this is 2. Therefore, fx is not differentiable x equal to 1. So definitely no lah, sebab dia tak sama kan kiri dengan kanan tu. Okay, so I have done number 6B. So let's proceed. Sekejap, dah kena kecilkan sikit. Tak cukup space ni. Oh, group first. Okay, so let us proceed with number 6C. Yay, nak habis dah. Okay, so 6C. So I have y cube equal to ln of x cube y square, and they want us to find dy over dx when y is equal to 1. Okay, so y is equal to 1. Let me find out what is the value of x first. So 1 cube is equal to ln, so x cube multiply with 1 square. So 1 is equal to ln of x cube. Therefore, x cube will be equal to e. X will be the cube root of e. So x is the cube root of e, y is equal to 1. So let me differentiate. So d over dx of y cube equal to d over dx of ln x cube y square. So differentiating this one, so we got a different variable over here. We need to use a chain rule. So d over dy of y cube times with dy over dx equal to, so over here we got a ln, so we're going to differentiate them first. So a ln will be 1 over x cube y square, and then of course we need to differentiate d over dx of x cube y square. Okay, so let me differentiate one by one then. Okay, so differentiating the left hand side, that will give me 3y square dy over dx. On the right hand side, so this one we need to be extra careful because we have to use the product rule. So one of them is u, another one is v. So u is x cube, and then of course I have to differentiate y square plus y square, and then we are going to differentiate x cube. Okay, so this is 1 over x cube y square x cube. So this one we're going to use the chain rule for them. So you will have 2y dy over dx plus with y square 3x square. So let me simplify this. So it will become 2x cube y over x cube y square dy over dx plus 3x square y square over x cube y square. Okay, so this is basically equal to 3y square dy over dx. Okay, so let me try to simplify them first before I bring it to the left hand side. So cancel out, cancel, cancel. So what do I have there is 2 over y dy over dx plus 3x square y square. Oops, that one can also be simplified. Dia hang lagi. Gosh. Okay, so this is 3, and then potong, 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 potong. So 3 over x. So this is 3y square dy over dx. Bring it to the left hand side. So I got 3y square minus 2 over y dy over dx, and this is 3 over x. So samakan pembawah dekat sini. So 3y cube minus 2 over y dy over dx equal to 3 over x. So dy over dx is simply equal to 3y over 3y cubed minus 2 multiplied with x. And then you're going to substitute y with 1. So 3 over 3 times 1 cube minus 2. And then the value of x is the cube root of e. So this is dy over dx. So dy over dx is equal to 3 over, so this is 3 minus 2, which is 1. So we got a cube root of e. So 3 over cube root of e. So that is the value of dy over dx. Okay, so I have done number 6b as well. 6c, sorry. 6c. So let us proceed with the last question, which is question number 7. So sekejap kita simplify sikit. Then we can do question number 7. Okay, so question number 7. Okay, so we got inverted cone. So let us catch the cone then. So this is question number 7, the cone. Okay, so the depth is 10. So that means from here to here, this is 10. And then the radius is 5. Okay, so this is 5. Right, so at the rate of, so we pour the water, so that means the volume will be increasing. So we got dv over dt equal to 8, then positive 8. Find the rate at which the depth of the water in the cone is increasing when h is equal to 4. Okay, so what is the question? The question asks for what is dh over dt. So what is this? When the h is equal to 4. Okay, so basically, where is h? So if this is the cone, the h is over here. So this is h, and that is r. Okay, so let me start from the question. So this is dh over dt. By the way, this is a rate of change, so that is why I always start with my question. So it's supposed to be dh over something, something over dt. So what do we have is dv over dt. So I do know this is dv, this is also dv, and dv over dt is actually equal to 8. So now the only problem is that I didn't know what is the value for dh over dv. So let us find out what is the formula involving a v. So the volume is actually equal to 1 over 3 pi r square h. However, if I want to differentiate them with respect to h, I have two variables over here. The first one is r, the second one is h. So I cannot simply differentiate everything with respect to h. Sebab kalau tidak, nanti dia akan jadi implicit differentiation. So I want to change everything in terms of h, so that it will be easier. So what happened here is that I didn't use this cone yet. So let us check the trigonometric ratio. So if I do a tangent, so if let's say this is our theta, so tangent is actually opposite over adjacent. So I know r over h, so that is for the small triangle. This is actually equal to 5 over 10. So r over h is equal to 1 over 2. So r is actually h over 2. So I do know for sure that v is equal to 1 over 3 pi h over 2 square times with h. So this one will become pi h cubed over 3 times 4, which is 12. So if I do differentiate them, so dv over dh, So this is 3 pi h square over 12, which is simply equal to pi h square over 4. So this is dv over dh. So let me replace this over here. So this one, I'm going to take the reciprocal. So this is 4 over pi h square. dv over dt is actually equal to 8. Okay, so this is 4 over pi. So the value of the h is 4. So this is 4 square times with 8. So I got 4, 4, 1, 2. So the value is actually 2 over pi. So you can actually find out what is the value for 2 over pi. Or you can actually leave your answer like this. Okay, so this is the end of question number 7. So I'll see you guys tomorrow for the second set. Right, so thank you, all done everyone. Bye bye, have a nice day.